Hi, folks who are just joining me. So say hello, and there's Ethan. Great. I'm going to just check in as you arrive. There's Paul. Hello, Paul. Amelie, I'm still missing the form from your family. If you could, scan it and send it to the school, that would be great. The permission form. You're the last one, so that'd be swell. But thank you for being here, Amelie. Let's see. And it's Isaiah. Isaiah Super. Thanks, Isaiah. And then I got Kiara and some people I don't know. If I don't see your name, you got to tell me who you are. Okay, Kiara, Malta, Kiara, Malta, Charlotte, Lauren, Sophie. And which Tim are you, Tim? It's Tim H. Got it. Thanks, Tim. And I've got Alessandra. I've got Ingrid and Felix. I've got Aslan and Linus. Good. Thank you for your patience. You can look on the board, see if you can do the warm-up problem while we're waiting. I just got to check everybody in for your credit. There's Stella, Inessa, Liam, gotcha. And I don't know, this is Mr. Weiss, so I don't know if you're in the right live stream for the Kennedy School. Paul, I got. You're all set, Paul. There you go. Okay. Okay, so let me tell you who I'm missing, and you can tell me if you're there. So from 9F, and they really need to be here. I still need Alessia. I need Zach. I need Corey, Avram, Timothy P, Allie, Julius, Michael, Clara, and that's it. Yes, it's working now. Thank you, Isaac. From 9E, I won't read off, folks. Isaac is there. Great. There, Isaac. Zach is there. Thank you, Zach. Good. For 9E, if folks are not there today, I'll do another one tomorrow. If you cannot, if some of your classmates could not make this today, or I'll just send the YouTube to those that could not be here. Thank you, Aslan. Super. Glad to hear it. And yeah, so I'll check people in as they come on. Cassidy, thank you. Here's what we're doing today. Ayala, thank you. Ms. Leitner, there we go. What we're doing is we're going to start a new idea, and that is combustion. So combustion, I'll ask somebody in a moment what it is, or you can Google it in the time being if you want. For now, though, let's start our warm-up problem. Okay, so some of you can please type. If you can't type on what you got, okay, I get it. But if those of you that are at a laptop, type an answer. What's one thing that's wrong with this? Check this out. This person writes that this is 3-propylpentane. So give me what's wrong with it. Or give me the right name, as Sophie has maybe done. Yeah, Liam, you're all set. Good. It's not a parent chain, Kiara says, a pentane. Good. So count the parent chain and see if you come up with the same answer as Sophie. Yeah. So Inessa has as well, and several of you've got that it should be actually hexane. So this is like wrong. Now, can you swing it around in your head? Whoop. Okay, so if I turn this guy up, there's more than one way to do it, but I could like cross this guy out, or I could rotate this one up and put two more up here. And if I do that, then let's see if Sophie's right. Where's the branch? Okay, Michael Ward is there. Thank you, Michael. Good. Anybody else just coming on, let me know. Good. It's an ethyl branch, so a branch of two, and it's on three, so 3 ethyl hexane. Let's check it. So 1, 2, 3, 4, 5, 6, or 6 this way, and 3, 1, 2, 3, and a branch of 2. So an ethyl branch on a chain of 6 looks good. Okay. And if you have like digit there, if you have somebody that, okay, I got Aaron now. That's good. Aaron, thank you. And I'm about to block you, whoever digit is. So sorry, you're either going to tell me who you are or you're out of here. So here you go. Bye-bye. Okay, but I got Julius and Corey. Thank you for checking in, you two. Sorry, this takes a moment, but that's life in online teaching. And there's Julius as well. Good. Let's see if I missed anybody else. Corsine and Isabella there. Terrific. Good. Corsine is here. Isabella is there. Good. Census, Benches, longer than 6. Exactly. Hello, Corey. And hello. Thanks all to joining me. Okay, so Alessi is there. Great. Okay, let me tell you one last time who is not there. So here we go. I do not have Avram yet, unless you're just on. And I don't have Timothy P. I don't have Allie. And I don't have Clara. That would be from 9F. From 9E, I don't have Leo, Jack, Matthias. I don't have Devante, Anton, or Kai. Digit was Alessia. Alessia? You mean Alicia? Alicia M? If that's the case, I'll go back and unblock her. User in this. Okay, it doesn't matter. Put user in time. Add moderator. Hide user on this. I don't know what to do. Okay, I can't get Alicia back in. She kind of blew it by putting a bunch of nonsense down. So I'll go back to the bottom, and now I can see who else is there. Oh my. Okay, so here we go. Okay, you're not blocked. Okay, very well. Okay, Timothy P is here. Okay. All right, so let's go ahead and start. All right, so here we go, folks. So what's combustion? Somebody want to type in? What do I mean by combustion? And you'll see where we're going with that in a moment. So what we're doing this period. Okay, Abram was watching. Okay, then I'll write Abram down. Yeah, it's when something's on fire. Okay, good. So combustion. Combustion reactions is what we're doing. Combustion is often about hydrocarbon burning. Yeah, when you burn something. So burning something, usually it's in air. But in air is really kind of silly. What is it? What is it that is in air that's really helping something burn? In other words, what does in air really mean? It means burning with what stuff? What's in the air that's very reactive? I'll wait for your answer. Alessia has it, as do Inessa and Sophie. It's O2. So in other words, with O2 gas. Let's do an example. Okay, ready? Here we go. Ta-da! All right. What's the good? A lot of you knew it. I'm pleased. Malta, Isabel, everybody knew it. Good. What's burning? What's in cigarette lighters? What's in the lighter? What's the alkane, please? What's the alkane in a cigarette lighter? Michael knows. Thank you, Michael. And Allie's arrived. Thank you for checking in, Allie. I'll check in just a moment. So we got butane is the correct answer. Now, if you look, and here, I don't know if you can hear it, it's a liquid. Ordinarily, it's a gas at room temperature, but it's a liquid because they have it under what conditions in this little container? Okay. So why is it a liquid in this container? What sort of condition might it be in? Normally, it's a gas at room temperature, but I can hear it's definitely a liquid because it's under what? It's under a high pressure. Good, Subliv, you got it. Okay, so let's take a what it is. So butane, I think all of you know, it's C4. H, if we use our formula, H10. I'm going to say liquid because that's burning. Actually, I'm not. As I do this, probably what's happening is it's coming out as a gas out of the chamber. So I'm going to say it's a gas because that's what it does at room temperature. Plus, you told me it's connecting with oxygen out of the air, O2 gas. And let's see what we make. So let me have you think about that. We make two things. Yes, Alessia, you're right. And I'm going to check in a couple more people while you're thinking. So what forms, in other words, what are my products? These are my reactants. What two things form? And let me just check in a couple folks who just came. I've got now, I've got Ellie. Okay, so I don't have Clara, but I got a lot of you others. Still don't have Leo, Jack, Matthias. Devante, you on there yet? Yes, thank you, Devante. Just arrived. Gotcha. Gotcha. Okay, and need Anton, Kai, Sina, and apparently I have Alicia. So I'll say yes, I have Alicia there too. I don't have Hannah. Okay. All right. What do you make? Yes, carbon dioxide, Kiara. Thank you. So carbon dioxide, O2, and that's a gas. What other thing is forming? Let's see if somebody knows. So in addition to carbon dioxide, something else is forming. Yep, CO2, that's carbon dioxide. Good. What's the other thing forming? Hint, it better have H in it because I got some H's over here that are not like taken care of. Not H2 gas, because that itself is burnable. Remember, we can burn H2 gas. You might have done that in eighth grade. It's something that you can see in the wintertime. Michael has it. Good. Not H2, although everybody wanted to guess that. Isaac has it as well. It's H2O. But check it out. Is it a liquid coming out? No. It must be H2O coming out of some form of steam. I don't see it, so it's a gas. You might say, Mr. Weiss, how can that be? Okay, think about it in the wintertime. If I see the back end of a car, okay, I can see the exhaust in the wintertime. Well, a car burns another alkane, octane, and what's coming out of there is CO2 and water. And what you see, you don't see the CO2, but you see the water vapor in the wintertime. Same with you. If I breathe on a cold day, I can see the water vapor, right? That's not the CO2 I'm seeing, it's the water vapor coming out of your lungs, right? Because your lungs give water to the air as you breathe it. Okay? Good. Thanks for everybody for answering. A lot of you had that. Good. Now we got to do something that you've done with acid-base reactions, but you haven't done with this, and that is balancing it. So here we go. C4H10 plus O2 forms CO2 plus H2O. Okay, clearly I don't have the right number of C's on each side. Here I got 4, here I got 1. What can I put in front of the CO2 to balance this sucker? Just a number. It doesn't work now, Abram. I got wrong number of C's. So fix it, Abram. How many C's do I got to have in front? What can I do here to balance this? 2 CO2. No, that would give me 2 C's. I need 4 C's. Remember that 2, folks, is for the oxygen. That's not for the C's. It's 2 O's, 1 C. Charlotte has it, 4. So we need a 4 in front of this thing. Now let's look. So I got 4 C's, 4 C's. Okay, next we're going to do the H's. And the H's, I got 10 H's here. I got 2 H's. So I need to figure out something in front of the water to help balance that. Good. Lots of you had that, including Corey, who had it many times. Corey, 1 answer is enough, please. Okay, righto. So what can I put in front of this? 10, H10, and here H2. If I put a 10 here, that's too many. That won't work. 10 times 2 would be 20. That's way too many H's. I need 10. 10 on this side. I need 10 over here. What to put in front of water? Alicia knows, as do a couple others. Linus as well. Good. Let's put a 5 there. So let's check it out. I got 4 C's, 4 C's. 10 H's. 5 times 2 is 10 H's. Okay. Now, you might say, Mr. Weiss, what's going on? How come you haven't done the O's? The O is part of what's called it comes in 2s, right? Brinkelhoff. Some we have that in Brinkelhoff. We had it earlier in the year. And my rule is, and I'm going to call it my rule, Mr. W's rule. Do the Brinkelhoff last. I don't care if it's O2 or H2 or what it is. In this case, in this type of reaction, it's O2. So do the Brinkelhoff. Remember when we did that? Last. Here's why. Notice how I got the O's in 2 different things. If I try and do the O first, it really ends up not working out very well. So let's do it now. I want another color. Let's see if I kicked it out of the way. There it is. Let's take blue. Okay, I got 2 O's. Here I got, how many? Well, it's 4 times 2, so I got 8 O's. But I got more here. I got 5 times 1. Remember, the 2 is for the hydrogen. So I got 5 times 2. No, sorry, I got 10 H's, but I got 5 O's, right? So who's following? How many O's do I have on this side? Yes, somebody wrote it. Alexandra is already there. I got 13. 8 plus 5 is 13 O's. And you might say, well, Mr. Weiss, how do I do that? What do I do? Okay, so I'm going to show you. Go over here. In front of O2, you're going to put a 13. And now, yes, I know it's wrong. Look at what I got. 13 times 2 is 26, right? 26. And I need 13. So 26 is twice as much as I need. So I need to cut that sucker in half. Watch, slow motion. 13 halves. Are you allowed to do that in chemistry? Yes, if you're, Michael, you're answering way too much. Yes, if you're not German. Germans really don't like fractions. I don't know why, but every international book that you look at, you'll find fractions in it. So my German colleagues, if you have chem in German next year, you're going to have to not do that. But if you have chem in English, you're going to be able to do it. I'm sorry it's that way. Here's what my German colleagues do. And maybe some of you, if you don't like fractions, you can get rid of them. What could I multiply the whole equation by that would get rid of those fractions? I'm tipping it because you got a glare. So I got 1, 13 halves, 4, and 5. How can I get rid of all that? What could I multiply the equation by? Yeah, okay, I got an unknown person, and that says unknown whatever by 2. That's correct. Exactly. I said it. Yes, but who are you? Okay, so so I'll say, or I could also do then 2, C4, H10. I'm going to skip the phases for now. Plus 13, O2 forms, and I got to squeeze this in. 8, CO2, plus, I've got to write it down here, 10, H2O. Both of these are correct. What you can't do is just multiply it by 4 or 100 or 1,000. It needs to be a lowest number of values, or it needs to be something, if it has a Brinkelhoff only, you're allowed to use fractions. So, Achtung, fractions only with Brinkelhoffs. With Brinkelhoffs. Those guys, okay? In other words, I can't have half a CO2. I can't have 3 halves of a water because I can't cut it in half. But O2, I can cut in half and I get 2 O's. So it actually makes, I hope, a lot more sense to you. Questions before we have you try one? Yes. Will we have to do this in the future if we have an American teacher for chemistry? You betcha. You betcha. Including not only for me the last couple of weeks, but we'll have some alkanes we'll be burning in ninth grade physics. Why? Because one thing I'm going to teach about is the car engine, and we burn something called octane. Ha. So it's going to come up again in physics. We're going to write the equation at some point for burning octane. What's a Brinkelhoff? I thought we did that, Sophie. Let's answer Sophie's question. Maybe somebody can answer it online. Okay, we're going to do another one of these in a second, but let's first remind ourselves, if you didn't have this last year, my poor people, what is a brain? Look how I spell it, Brinkelhoff. It's an Eselsbrücke, right? It's a way to remember something. So these elements do what? Does somebody know? Good, Kiara, they come in twos. Another way to say that is they are diatomic. In other words, if you find it in nature alone, not in a compound, okay? If you find it alone, you'll find there's Br2 out there. There's I2, there's N2, Cl2, that's 2 letters, H2, O2, you know about that one, and F2. All of those come in twos if you have them alone. It doesn't mean they always come in twos. Like CO2 has only one C, but it has two O's. H2O has two H's, but only one O. Even though H2O has two Brinkelhoffs in it, they're not alone, they're in a compound. So these, if they're elements, they come in twos. That's probably much more, Sophie, than you wanted to know. Okay, carbon, yeah, carbon is not a Brinkelhoff. Nope. Carbon basically comes in C, and it's as many C's as are in a chunk of diamond or a chunk of graphite. Right, okay, let's try another combustion reaction. Okay, so let's have you guys do one. I'm gonna do one more, ready? I'm gonna do a hard one here. Since it's Christmas time, we're gonna live it up a little bit. Ta-da! Okay, so yes, a candle's made out of alkanes as well. So we're gonna do the formula for candle wax. Okay? Now, can I put this on here without burning things? I think the answer is no. So I'm going to just put it there. I don't want it to fall and burn me. So candle wax is another example of combustion. Okay. Candle wax, to be honest, it's many alkanes, okay? It's not pure. But the main one in there is mainly C25H. Well, how many H's would it have, gang? It's an alkane, so can you tell me how many H's that sucker would have? Do the math real quick. If it's C25, which it is, H, it would be how many? Alessia's got it. Alessandra, Paul, good. All of you, good job. So 52, double it, 50, and add 2 more. Okay, here we go. Yes, it's big. Can you do it? Yeah, because you can do mental math. It's not that hard. Okay, so here's our thing. We're going to do C25H52. Now, interestingly enough, what phase is it? Well, to be honest, it starts out as a solid, does it? Although it comes up the little wick, and there it's a liquid. So I don't really know what to call it. Let's call it what it is right now as we're looking at it. Can we? Let's call it a solid. Okay, folks, if you want to make funny comments, I'm going to reward you by eliminating you on the comments. So forget the comments unless they're pertaining to chem or if you got a question. Got it? All right, thank you. Next one, you're gone. Okay, plus what? Forms what? All right, look back at the notes you just took. All right, thank you. So what are we combining with and what 2 things are my products? See if you remember from a moment ago. Plus O2, thank you, Charlotte. And that's a gas because it's in the air. And then the 2 common things that we're making. Good, a lot of you knew that. Some others type in, what are the 2 products, please? Either in words or symbols. Words or symbols. Alessandra has 1, as does Michael. That's CO2. That's one we don't really want to make a lot of in our world because it's warming up the atmosphere, but that's what it is right now. And the other one again was, yeah, good, Charlotte. And Ingrid's got it. So I'll put it down here, water. And again, we can't see the water coming off, so we're going to assume it's a vapor, a gas. Okay, you ready? I know the numbers are scary big, but you can do it. It's not really that hard. Let's balance the sucker. Good, a lot of you got that. Thank you. Yep. Aslan, Felix, Paul, everybody's got it. Good. Balance this sucker. Remember, we're going to do O2 last. That's my rule. So we're going to do C's first. C25, CO2. What do I put in front of the CO2? How about Corey? You're going to do no more comments, Corey, or you're out of here. Thank you. How about an answer from Corey? 50 would be too much. There you go. There you go. Okay, so 25 C's, and I got to fix it in here. 25 C's. So I got a 25 in front of CO2. So 25 C's, 25 C's. Help me out with the H's. Now we don't need 25 halves. We just need 25. 25 C's, 25 C's. Remember this 2? That goes with the O. That doesn't go with the C. It's only 1 C, 2 O's. 25, 25. But the other one, let's fix. Okay, water, H2O. This one, H52. Holy moly. So what do I got to put in front of H2O to balance the, how can I get 52 H's out of this sucker? What to put in front of the water? Sophie's got it. So does Aslan. Okay, let's put it in there. So it turns out it's 26. I'm going to move that over a little bit. 26 times 2 is 52. And that's what we need. Okay, now we got to do the O's. Yes, it's a big number. Yes, you can do it. Okay, so this guy, 25 times 2, all right, to give us the O's. So I got what, 50 O's out of the CO2, 50 O's. Plus, that's 26 times 1. Remember, the 2 goes with the H. So I got 26 O's. 26 O's plus 50 O's. Let's get the candle out of the way. And what do we got then? So we got 76. Is that what you came up with too? It is. Thank you, Alessandra and Aaron. So 76 O's. All right, so what do I put in front of O2? Well, I put what? What's half of 76? A lot of you got it. Man, some of you are quick. I love it. And Nessa's already got it. Alessia, half of that is an even number. I don't have to put a half or anything. It's exactly 38. Don't believe it? Let's do it over to the side. 38 times 2, 16. 6 plus 1 is 76. Ta-da! So 38 O2s, and you are balanced. Good. Any questions from any of you? I'm going to have you try a couple of these. And before I go on, let me just do one last time. I want to make sure I've got everybody. So I last check, I don't have Leo. Let me know if you're there. Jack, Matthias. I don't have Anton, Kai, Sina, or Hannah. And out of 9F, I got everybody except for Clara. So Clara, let me know if you're there. Other than that, I'll send it to her if she's sick or something. Okay. And we just removed them. Bye-bye. Okay, so here we go. How are we doing on time? But we still got 8 minutes. I'm going to have you try a couple of these. All right, your turn. A, 3-methyl heptane. Burns in air. Reaction? Tricky, huh? You got to do some thinking, don't you? Because you got to come up with the molecular formula, don't you? How many C's and how many H's? All right, so next one, let's do 2, 3 dimethyl pentane. Burns in air. And I want the reaction. So do it on a sheet of scrap paper or do it in your notes. And a lot of you are figuring this out already. I'm going to write what some folks say. What does the board say? I'll read it off. So it says 3-methylheptane burns in air, and I want you to figure out the reaction. And then for part B, it says 2,3-dimethylpentane burns in air, and I want the reaction. So you got to kind of mentally figure out what the formula is, don't you? Heptane, you know what that is, but if I had a methyl, then we got a different number of H's. And I see one person, and I see a couple people with the right number of H's. Remember, 3 is the location. That's not the number of C's. Okay? 3 is the location. So here we go. 3-methyl. Okay, so I got heptane is what? 7. And a methyl group is 1. So I got what? C8. So a couple of you did have it. So Paul had it, Zach had it, and there we go. C8H. What? Let's see. Double it. Add 2. 18. We don't know what phase it is, so we'll leave that off. O2 gas forms. And it always forms the same thing. Now, does it always form water and CO2? Yes, but it may form other stuff as well. It may form carbon monoxide and some other things if it doesn't burn completely. But to be honest, the most common products are CO2 and H2O. All right, you balance it. Okay, in the meantime, can someone else help me get this one, the formula? Okay, we're going to balance that, but we'll come back to it. 2,3-dimethylpentane. Well, you know, pentane has how many? And then you got dimethyl, so I got 2 methyls to add into that, so you got to add up and get your total number of C's. Okay, how many C's do you have? So C what? Sophie's got it. Let's see if other couple people jump in here. Yeah, pentane's 5, and then I got 2 methyls, 7. She's got it. Let's see if some others got it. Kiara got it, Malta got it, and Charlotte. Good. And then H, to balance that, double it, add 2, 16. Good. Plus O2, that's a gas. And the other 2 are going to be gases as well. CO2 plus H2O. Those are both gases. And gas. Let's go back and balance. Okay, let's go back and balance. So C8H18 plus this one. Okay, so let's balance. I got what? Eight of these. So I'm going to have in front of the CO2. I know it's a little glary, isn't it? And some of you got it. So I need in front of here, what? 8 of these guys, right? What about H18? So I need what in front of my water? How do I get 18 H's out of there? 18 here and here. I got to put a No, it wouldn't be a 4, gang. If I got C8, remember the O is for the 2. The 2 is for the O. There's one C, so I need an 8 in front here, not a 4. So be careful. And for the other one, I need what in front of here? What do I need right there? Some of you got it. Zach has it. I said it before. You probably did, Liam, and I just can't catch everybody. Corsine has it. Good. So I got 9 of these guys. Okay, let's add up our O's and see what we can do. Okay, so how many O's out of here? 8 times 2, like it's 16. And then 9 times 1. So that gives me a total of 20, 25. All right, come back here. 25 is an odd number, it's just the way it is. I can't cut it in half. So what fraction could I put there? Good. Yeah, a couple of you have it. So I could put 25. Oh, but that's 50. I need half of that. 25 halves. Or we could say 25 over 2. Or if you get a German teacher, multiply everything by 2. Right? 25 halves, right? Because I need 16, but I need 25. 25 halves, so 50 divided by 2 is 25. Okay, so let's see. If I have a German teacher next year, I'd go 2, 25, 16, 18. Let's continue. The bottom one, unless we got a, yeah, Mia M, I'm from 9B. Okay, bye-bye, Mia. Go somewhere else, please. Please check out. Okay, so C7, let's fix this guy. Okay, how many C's, how many CO2s do I need to balance this? And I'm getting people who don't belong here, so I'm going to get rid of them. Bye-bye. Okay. All right, so how many CO2s? I need, exactly, thank you. Kiara and some others said it's 7. And let's see how many waters I need. So H2O, I got 16 H's here. How many waters do I need over there? And a lot of you are still catching up here. That's fine, it's a little lag here. So you can tell me how many waters I need now. 16 H's, so I need, good, a lot of you got it, 8 waters, thank you. And Ingrid and others have it, and Alicia, good. All right, let's add up the O's, here we go. 7 times 2 is what, 14? 14 O's plus 8 more from the waters. That's easy, right? Makes 22. So give me a number to put in front of the O2. I don't need a fraction, do I, this time? What can I put in front of O2? Some of you are quick on the draw. You must have good net service there. Thank you, Alessandra. And let's see if some others are responding as well. Good. Ingrid, Sophie, Lauren has it as well. Good job, everybody. So 11 of those. Yeah. Why am I teaching you this? Because as you could probably guess, everybody's getting it. Good. I'm teaching you this because we burn as a society lots and lots and lots of alkanes. We burn them in the kitchen. We burn them in lighters. We burn them in candles. We burn them, lots of them in automobiles and jet planes. And you need to know what those reactions are. And you need to realize that they're all forming CO2, which is not such a good thing, right? So we can talk about that more when we get to energy and alternative energy, which would be one of our topics next semester when we study that in physics. Okay? That's what I got for you today. So I'm going to wish you a Merry Christmas. I won't see most of you because I think I'll send this then to 9E as a YouTube and they can watch it. And so I'll just say all the best to you all, and I'll check in January with some assignments and some live streams to tell you what to do then. Until then, have a good rest of the year. Stay healthy and think chemical thoughts. Bye-bye.